In this lecture, I'm going to talk about female physiology. Production of female gametes is called oogenesis. So female gametes are eggs, or technically they're known as ova. So anything that begins with OO is going to be referring to the female, and specifically to eggs. The development of the eggs, or oogenesis, in the female begins while she is in her mother's womb, while she's a fetus. But much of the process is similar to that in males for spermatogenesis. For instance, the stem cell in females is called an oogonia rather than a spermatogonia. And this will go through mitosis to produce primary oocytes. These are going to develop in follicles. The oocytes develop in follicles, and the primary oocytes begin in the primordial follicles. This primary oocyte is going to be the one that goes through meiosis. And this process begins also in the womb. And then primary oocyte freezes in prophase 1 and remains there until much later in life. So when the female is born, she has all the primary oocytes that she is going to have for her lifetime. Or at least we presume that's how it happens. So the primary oocytes remain frozen in prophase 1 until she reaches puberty. And then once a month, there's a handful or so that are going to develop a little bit. And one of those might get to develop further and go through the rest of meiosis. And that one is known as the dominant follicle. So once a month, there's one that gets to progress past prophase 1. So progressing through meiosis 1 produces two cells. One is called a secondary oocyte. This is the one that's going to become the ovulated ovum. And the other cell is the first polar body. So this is different than meiosis 1 in males, which produces two haploid cells that are identical to one another. Secondary oocyte and the first polar body are different in size. Secondary oocyte is larger. It gets the majority of the cytoplasm and the organelles, and the other one is much smaller. So the actual ovum doesn't develop unless the cell gets fertilized by a sperm. So the secondary oocyte actually arrests in metaphase 2, then it ovulates, that is, it's ejected from the ovary, and nothing happens to it. It just disintegrates basically if it's not fertilized. So when if a sperm penetrates it, then it's going to complete meiosis 2, and then it becomes the functional gamete, the ovum. And that also, meiosis 2 also produces another cell, the second polar body. This figure correlates the events that are occurring with the oocytes and the follicles that are surrounding and nurturing and supporting the oocytes. So before birth, the oogonium, or the stem cell, is going to divide mitotically to give rise to the primary oocyte, which is within the primordial follicle, and that's still a diploid cell. It arrests at prophase 1, so it hasn't completed meiosis 1, and it's still a diploid cell, and it's still contained within the primordial follicle until she reaches puberty. And then each month, a select number of these oocytes are going to continue through meiosis 1. They're going to have two daughter cells that are distinct from one another. The first polar body, which is small, and the secondary oocyte, which is large because it gets most of the parent cell's stuff, the cytoplasm and organelles. And this is the one that's going to go through, potentially, meiosis 2 to develop into an ovum, potentially. So there are a lot of similarities between spermatogenesis and oogenesis that will help you to learn the processes, but there are also some really significant differences. For one thing, the result of spermatogenesis is that each spermatogonia produces ultimately 4 sperm, whereas each oogonia is only going to produce 1 viable ovum. The oocyte that's going to potentially become that viable ovum has to get from the ovaries to the uterus, so it gets most of the parent cell, cytoplasm, and mitochondria and other organelles to fuel it on that journey. The other cells, the polar bodies, just disintegrate. And the error rate is significantly higher in the female than in the male process. That is to say that the chromosomes don't segregate properly 1 out of 5 times in oogenesis. So the developed oocyte is going to have the wrong number of chromosomes, whereas that happens a smaller amount of the time in spermatogenesis. The ovarian cycle encompasses all the events that are associated with developing the mature egg. And the cycle occurs approximately once every month, although there's a great deal of variation. Ovulation, when the mature egg is ejected from the ovary, occurs in the middle of the ovarian cycle, and it separates the cycle into 2 phases. The follicular phase, which comes first, and this is where the vesicular follicle with the antrum is going to develop. That leads to the ovulation. And then following that is the luteal phase, where the corpus luteum, which represents the old vesicular follicle with the ejected oocyte, corpus luteum is left over, and that develops in the so-called luteal phase. To begin the follicular phase, a primordial follicle is going to become a primary follicle. And this process can take almost a year before the actual ovulation event occurs. So as a primordial follicle becomes a primary follicle, its squamous-like cells are going to become cuboidal. So after puberty, one of these primordial follicles is going to develop into a primary follicle once a month. And then that's going to develop into a secondary follicle. Those cuboidal follicular cells are going to change into a stratified epithelium. So it's starting to thicken around the oocyte in the interior of the follicle. Then that secondary follicle is going to develop to the vesicular follicle, which has this antrum, which is a fluid-filled space here, which is beginning to form in the early vesicular phase here. And when this antrum gets big enough, the oocyte is going to be hanging on back here at the back of the follicle until eventually the antrum reaches the surface of the ovary and ruptures, and it's going to eject the oocyte into the peritoneal space outside the ovary, leaving behind the corpus luteum, what's left of the follicle. So from primary to secondary follicle, the follicular cells continue to grow, and they're going to go from cuboidal to stratified epithelium. And now the cells are called granulosa because there's more than one layer. And as the secondary follicle becomes a vesicular follicle, a couple different layers are going to form. The theca folliculi is forming around the follicle, and then the zona pellucida, it's a thick glycoprotein-rich membrane that forms around the oocyte. Meanwhile, the antrum starts to form a fluid-filled cavity that's going to form around the oocyte. And towards ovulation, that vesicular follicle, the antrum is going to continue to grow, continue to expand with the fluid. And eventually the oocyte is going to be sitting at the back of the follicle, more or less connected to the side of the follicle by a stalk. So the follicle grows and grows and grows because of the growing antrum until basically it bulges from the surface of the ovary. During follicular phase of the ovarian cycle, several different follicles are going to be stimulated to growth by rising levels of follicle stimulating hormone, which again is coming from the anterior pituitary gland. In the middle of the follicular phase, rising estrogen levels are going to cause FSH, follicle stimulating hormone, to drop. When FSH levels drop, one of the follicles is going to predominate. The other ones are going to deteriorate. So the one that's left over to develop is going to be called the dominant follicle. That's the one that can ovulate. Inside the vesicular follicle, the primary oocyte is going through the rest of meiosis 1. It was arrested in prophase 1. As the follicle develops, the oocyte inside is going to continue through meiosis 1 form what's known as the secondary oocyte. And the other cell is a polar body. The secondary oocyte is going to arrest now at metaphase 2. So it was arrested as a primary oocyte in prophase 1. That primary oocyte, the dominant follicle, continues through meiosis 1 and continues up until metaphase 2 and then arrests. And it's going to stay here at metaphase 2 unless this particular oocyte gets fertilized by a sperm. This figure correlates the events that are occurring with the oocyte to those of the follicle which surrounds the oocyte. So the whole process of oocyte development, oogenesis, begins in the womb. The female is a fetus in her mother's womb. Her stem cells, the oogonia, will undergo mitosis to produce a number of primary oocytes. These primary oocytes are going to begin meiosis and arrest at prophase 1 until she reaches puberty. And then each month, a select number of these primary oocytes will continue to develop. Meanwhile, the follicle that surrounds the oocyte is also developing from a primordial follicle to a primary follicle. The squamous cells develop into cuboidal cells, and then those cuboidal epithelium transitions into a stratified epithelium with a secondary follicle. The antrum, this fluid-filled space, begins to develop in the vesicular follicle. And as the follicle develops as a vesicular follicle, this is going to induce the oocyte to continue through meiosis 1, producing a large secondary oocyte and a small first polar body. And the secondary oocyte is going to be arrested at metaphase 2. The antrum continues to develop until it reaches the ovary surface and it bursts, ejecting the oocyte. So this ovulated or ejected secondary oocyte is going to remain arrested in metaphase 2 until it gets penetrated by, when and if, it gets penetrated by a sperm. At which point it would continue through the rest of meiosis 2. And then at that point it could be rightfully called an ovum. Ovulation, when the vesicular follicle reaches the surface of the ovary and injects the oocyte into the peritoneal cavity, results from rising levels of luteinizing hormone. On occasion, more than one oocyte might be ejected, and both of those then could get fertilized potentially. That would result in fraternal twins. The oocytes were not identical and the sperm were not identical, so the twins are going to be fraternal, they're not going to be identical. Identical twins result when you get one oocyte that gets fertilized, and then it separates into two daughter cells that then become fetuses. Meanwhile, back in the ovary, the follicle is going to fill with blood where the antrum was, and what's left behind of the granulosa and the thecal cells is going to be called a corpus luteum. So luteinizing hormone is creating the corpus luteum from the follicle. And this corpus luteum, or yellow body, is going to be left behind in the ovary to secrete progesterone and estrogen. And these hormones are going to be there to help nurture the developing pregnancy, should there be one. If there is no pregnancy, then the corpus luteum is going to degenerate. And again, if there is a pregnancy, then the progesterone and the estrogen that the corpus luteum is producing is going to help maintain that pregnancy. Eventually, the placenta will take over, producing the hormones that are required. The events of the ovarian cycle are under hormonal regulation. It's the rising and falling levels of hormones that drives the production of the oocyte and development of the follicles. Early in life, the ovaries are producing small amounts of estrogen, which are going to negatively feed back on the hypothalamus to inhibit release of gonadotropin-releasing hormone. So therefore, the anterior pituitary isn't going to release LH or FSH. Initiation of puberty depends on fat content of the female's body. So fat cells secrete the hormone leptin, and when she gets to the proper age, if she has enough fat in her body, then she will produce enough leptin, which is going to reduce the sensitivity of the hypothalamus to estrogen. So basically, the rising leptin levels is going to counteract this inhibition of the hypothalamus. Now GnRH is going to get released, and that's going to stimulate the release of follicle-stimulating hormone and luteinizing hormone from the anterior pituitary. So the inhibition of the hypothalamus is relieved, and the gonadotropins, LH and FSH, are released, and their levels will continue to rise for several years until the basic pattern has been established, and that brings about the first menstruation, known as menarche. Remember that gonadotropin-releasing hormone, which comes from the hypothalamus, is going to travel to the anterior pituitary, and it's going to cause a release of SHH and LH. And those are going to travel to the gonads, the ovaries, and stimulate production of the follicles and sex hormones there. So early in the follicular phase, the hypothalamus is going to act on the anterior pituitary via gonadotropin-releasing hormone. Anterior pituitary releases follicle-stimulating hormone, which is going to cause the granulosa cells to release estrogens. And then at the same time, anterior pituitary is releasing luteinizing hormone, which induces the thecal cells to release androgens, which are the male hormones, but these androgens get converted quickly into estrogens. And together, the estrogens from the granulosa and from the androgens of the thecal cell, these estrogens are going to have a negative feedback effect on the anterior pituitary and the hypothalamus. So small levels of estrogen has a negative feedback effect. Lots of estrogen, such as produced by the follicle before ovulation, large amounts of estrogen have actually a positive feedback effect, bizarrely. So enough estrogen is going to cause the release of GnRH and release of LH from the anterior pituitary. So there's a surge in luteinizing hormone, and luteinizing hormone leads to the production of the corpus luteum, for which it is named, luteinizing hormone. So luteinizing hormone, in other words, is going to lead to ovulation, because ovulation leads to the corpus luteum. Now estrogen levels return to normal, and again there's a negative feedback effect on the hypothalamus and the pituitary. So follicle stimulating hormone levels go down because of increasing levels of estrogen, as well as inhibin, which is released by the granulosa cells. So these two things together cut back on the amount of FSH. So there were several follicles that are developing at this point in time. Only one of them is going to be able to continue past the reduction of FSH levels. The other ones are going to disintegrate. As that dominant follicle continues to develop, it's going to continue to produce estrogen. When those estrogen levels peak, again, there's a brief positive feedback rather than negative feedback. So it's going to trigger a surge in luteinizing hormone release. The surge in luteinizing hormone is going to lead to ovulation. That primary oocyte is going to continue through meiosis 1. Remember, it was paused or arrested at prophase 1, so it was still a diploid cell. It's going to continue through meiosis 1 now because of the rise in OH levels. It's going to become the secondary oocyte as well as the first polar body. Then the secondary oocyte is going to continue on to arrest at metaphase 2. Also, luteinizing hormone is going to, around the follicle, it's going to increase the vascular permeability. It's going to trigger a localized inflammatory response. It involves the release of metalloproteinase enzymes. And these metalloproteinase enzymes are going to weaken the ovary wall. And this is going to cut back on the flow of blood to the follicle. So the cells, the wall is going to immediately begin to thin. It's going to rupture from the ovary. And then the oocyte is going to get ejected. After ovulation, luteinizing hormone is going to lead the follicle to become the corpus luteum. And the corpus luteum is going to secrete progesterone and some estrogen. Whereas progesterone is going to be important to maintain the structure of the stratum functionalis, that inner functional layer of the endometrium of the uterus. Meanwhile, LH levels will begin to drop as well as FSH due to the rising levels of progesterone and estrogen. So they're going to have that negative feedback effect on the hypothalamus and pituitary. And inhibin contributes to that inhibition. So this is going to lead to the end of follicle development for that particular ovarian cycle. The corpus luteum will persist for a while. If there is a pregnancy, it's going to provide the progesterone and estrogen that the uterus is going to require before the placenta develops to the point where it can take over with hormone production. But if no fertilization is going to occur, then the corpus luteum is going to degenerate. And so the production of estrogen and progesterone declines, which is going to remove that negative inhibition of the gonadotropins here. So the cycle will start all over again if there's no fertilization. The uterine or menstrual cycle follows the events that are occurring in the uterus that correlate with what's happening in the ovarian cycle. There are 3 phases to the uterine cycle: the menstrual phase, the proliferative, and the secretory phases. In the first 5 days of the uterine cycle, the menstrual phase, there's a decreased amount of ovarian hormones. So estrogen and particularly progesterone that are being made by the corpus luteum are decreasing because the corpus luteum has degenerated. So lack of progesterone is going to cause stratum functionalis to be shed from the uterine wall. Then the next phase is the proliferative phase, which occurs before ovulation. And here, rising estrogen levels from the developing follicles is going to produce a new stratum functionalis layer. This is also going to prepare the uterus for potential passage of sperm. And then this period ends when ovulation occurs, generally about day 14. Now, after ovulation, we get to the secretory phase, which is when progesterone is helping to prepare the endometrium for a possible implantation. And there's a period of about 10 days after ovulation where the corpus luteum is producing progesterone. The changes occurring during this phase include the stratum functionalis is becoming a secretory mucosa in order to secrete nutrients that the developing embryo would potentially need. Also forming a cervical mucus plug that's going to prevent the entry of any other sperm or etc. into the uterus. Then if there is no fertilization, again the corpus luteum is going to degenerate so that there's no more progesterone being produced. This is going to cause the endometrium to go through a series of changes where it's going to slough off the functional layer, stratum functionalis sheds. And then we start all over again with day 1 of the uterine cycle. Menstruation has begun. So let's compare the events of the ovarian cycle with those of the uterine cycle, because there's a correlation, of course. Now, pituitary gland hormones are driving the events of the ovarian cycle, and that produces fluctuating levels of ovarian hormones, which drive the events of the uterine cycle. So this is all related. Alright, so rising levels of ovarian estrogens is going to lead to a decrease in follicle stimulating hormone. There's a negative feedback on the hypothalamus and pituitary due to the estrogen levels. That leads to the development of the one dominant follicle, which is going to ovulate in the middle of the ovarian cycle. And that occurs because there is a rise then in estrogen level. Once it gets to a certain peak level, there is actually a positive feedback back on the hypothalamus and the pituitary gland that leads to the surge in luteinizing hormone and FSH. So the luteinizing hormone surge is going to lead to the ovulation, which is going to develop corpus luteum. And of course, the corpus luteum is going to be producing progesterone and some estrogens. The uterine cycle begins with the menstrual phase, and this shows the development or deterioration of the endometrium, stratum functionalis here. And it was declining levels of ovarian hormones, particularly progesterone, that led to menstruation in the first place. And then there is a rise in estrogen, which is going to lead to the proliferative phase, where the endometrium, the functional layer of the endometrium, is being rebuilt. So this all occurs before ovulation, and then post-ovulation there's that rise in progesterone that's going to lead to the secretory phase of the uterine cycle, in which the functional layer is being supplied with a bunch of blood vessels in order to nourish that developing embryo should it happen, should the fertilization happen. And so this corresponds with the luteal phase because it takes the progesterone from the corpus luteum, whereas the menstrual and the proliferative phase corresponds with the follicular phase of the ovarian cycle. Alright, so let's summarize the effects of the ovarian hormones, your estrogens and progesterone. Remember, there are several different estrogens. The main one is estradiol in humans. And estrogen is similar to testosterone in males. It's going to promote the development of the female gamete. And it also promotes the development of the follicle, which of course surrounds the developing oocyte. And then, like testosterone, estrogen in females is going to lead to the development and maintenance of the secondary sexual characteristics of the female. It has anabolic effects, much like testosterone, and also metabolic effects like testosterone in the male. And also, importantly, estrogen is important for efficient calcium uptake in the female, which is an issue with postmenopausal women and osteoporosis, of course. Progesterone is produced in high levels during the luteal phase of the ovarian cycle, and is going to promote the secretory phase of the uterine cycle, where there are those changes in the cervical mucus and the development of endometrium, the functional layer of endometrium in the uterus. And should a pregnancy occur, progesterone is going to have some important roles to play in maintaining that pregnancy.